Yes, absolutely correct. Okay, so yeah, then what we were doing, we were doing this question, and then we reached this point, right? So we reached this point, and let's say that we reached this equation. So let's say your cos theta is x, right? Your cos theta,
These maths classes will go till which day? All these classes.
yeah. So all these class will what?
No, like when will these class finish? Like before the exam starts?
Yeah, before the exams. Yeah, before the exams. That will then will stop the results class because you need a preparation time, right? Or you need a third gigabit. It will yeah. Yeah. So can you hear me?
Yes, yes.
Yeah. So yeah. So the classes will continue until the exams, right? The exam starts. Then stop. Okay. And in the meantime, in between exams, when you face any trouble or any doubt in any of the question, you can always yeah, tell and then we can discuss these questions. Okay, so the question to you now is that you have this quadratic equation, and let's say that let's say that cos theta is x. Then you please find out the value of cos theta from here. What would be x? Please solve this equation. What would be this?
We can take x common, x outside,
This is
then x
what
outside,
is
then
the
x.
what is this equation?
So quadratic equation.
So what is the solution of quadratic equation? Alpha and beta are minus b, right? Minus b plus minus d by 2. This is minus d is how much? D is b square minus 4ac. This is root 3 square minus 4. A is 1, c is 1. So this is 3 minus 4. So this is imaginary one. Why are we getting this imaginary?
No, but can't we solve it using the middle term splitting?
Middle term, because this is a root, so it would be easy to solve by this method, right? So it would be easier to solve by this method. And where did we do a mistake? Did we do a mistake? Yeah, let's
If so, whenever there is a root, we should use the
yeah
quadratic.
quadratic one. So that would be easier to solve. The quadratic one would be easier to solve. So where did I do the uh, 3 and minus 2 to the cos theta plus cos square theta, and then this is 1 minus cos square theta, 1 minus 2 cos square theta, 3 minus 2, and then this is 1 minus 2 cos square theta, 3 minus 2 cos theta, minus 2 3 cos theta, plus cos square theta minus 1 plus 2 0. This is cos square theta minus 3 cos theta plus 2. This is what we are getting right. Then, yeah, b square minus a is 1, c is 1. Okay, why this is happening? We have to do this question again, right?
Can I copy it? The last.
Yeah. So we have to no. So what we now we have to solve this equation. So let me So let's do this in a different right. This is what we did last class. Remember, we have to find out this one minus sine theta cos theta. So there is another simple way that we can do this problem, right? And because this is root 3. So how can we get rid of this root 3? How can we do that? How can we get rid of root 3?
Squaring.
So squaring. So squaring both is that gives square both this. So squaring both the sides, what we will get, this is sine theta plus cos
Plus
theta.
cos theta, the whole square.
And this is
Then root 3 square.
this
So
is
that
sine.
is one.
Yeah.
Yes, I guess.
What would be this?
But isn't that one? Because the identity sine square
So
plus
I did this is 1, right? This is 1, not this one. This is whole square, a plus b whole square. So we have to first simplify this. What would be this thing?
so that will be sine square plus 2 sine theta cos theta plus cos square theta.
Because this way, this is the simple, right? Yeah, this one
Now
is
this will be
this
sine
is
square and cos will be 1
and
plus 2 sine theta.
this was simple question, right? Why did we complicate this question? This one will go the other side, and then this is 3 minus 1, so sine theta and into cos theta, that is how much? By 2. So this is
This
1.
one.
So if we put this value in here, so what we will get? We will get 1 by 1, which is 1, which is RHS. So that was this question. Yeah, so this was simpler. So we had to square this thing, not take this thing the right hand side and then square.
So whatever we did right now was wrong.
Yeah. So that is, we'll ultimately get the solution from that one also. But this
Mm.
is the simpler one. This is the simpler. So please note down this part. Right?
Yeah, because in the OR question it was very simple, so I don't think it will be that lengthy like this one.
Yeah.
The OR is that simple.
Yeah. So this is not that much lengthy, right? Yeah, whenever you put it down, please tell me and give me compliments that
We finished.
Yes, whenever you have put it,
Yeah, finished.
yeah, so the second part is that you already know. So how do we represent all the trigonometric ratios in the form of the other one, right? Unspecific. In this question, they have told us, right? Every trigonometric ratio in the form of quasi, right? So yeah, this one is the simpler one, and this one is this one. Yeah. So this you already have these, right? This you can, right?
But in the seventh one, A, it is telling sine theta plus cos theta is equal to root 3, then prove tan theta plus cot is equal to 1. So we
Yeah.
should prove that, right?
So we proved that one, right? Right? We proved that tan
Yeah,
theta.
we already proved, but you said that is wrong.
No, no, no. So we proved just now, right?
Yeah, we proved, but the one which we proved, the quadratic equation one, that's wrong, right? We have to
Yeah.
do sin
So
theta plus
yeah, that
cos.
is yeah. So from that we didn't get the solutions. From we have to only square this thing. We will square this thing. We will get sine theta cos theta as one, right? From this thing we are getting. From this one we are getting this thing. And then if we solve this thing, so in the last we got 1 by sine theta cos theta. Then we use this thing and we write the value of this thing as 1, so then it is 1. So tan theta plus cot theta was 1. But we use this idea, right?
Yeah.
So yeah, the method that we studied now, that is the correct. Just remember the last one. This, okay, so what, yeah, do you remember? What is the first thing that we write in this one?
So
What is,
CK is hypotenuse by perpendicular.
yeah, but we have to write cos A, sec A, cot A in terms of cos sec A. This is the equation. So we don't use, yeah.
Mm.
So in this type of question, what is the first thing that I told you earlier?
We draw a triangle and find out all the the values of it.
So this, yeah, in this question, they didn't give any value, right? So we have to write other trigonometric ratio in terms of possibilities. Do you remember, first we write reciprocal one. That was the idea, right? What is the reciprocal of cosec A?
Hypotenuse by perpendicular.
Reciprocal of cosec A, right? Reciprocal. What is 1 by cosec A? That is what I'm asking.
Sine.
Sine. So first thing that you can write is that sine A is 1 by cosec. So you have written sine in terms of cosec, right? And then you can write, and then you can write the identity one. So what is the identity related to cosec A? What was the identity?
Oh yeah, it's cos square A plus 1 equals to cos.
Yes, cos square A plus
Cos square A plus 1 is equal to cos.
no, no, no. There are only three identities, right? One is this one,
Yeah, cot square plus 1.
cosec minus cot square A, that is 1. So from this one we can find out cot A, right? So what would be cot square A? That would be how much? How much would be that?
You should write the identity or just the
No, this thing we have. So this is the identity. Then we write cot square A.
cosec.
This would be cosec square A minus 1, right?
Yeah,
And then we find out what is cot A. This would be how much? What would be cot A then?
cot A will be cosec A minus 1.
This should be true, right? Of right. This is
Oh,
square, so
yeah,
it's so
yeah, yeah.
this is the answer. So this is cot A in terms of cot A in terms of cosec A. This part we have written, right?
Yeah.
And then what we can write? So we have
We know
sine.
sec square A, there is also a formula. I mean, identity.
Yeah, so sec square is related with tan, but we don't know tan, right? We don't know tan, so then we will right, then we will skip that part. But we know sine, from sine A we can calculate cos A, right? Right?
Yeah,
So how much is cos A? Cos A is of 1 minus sine square A, right?
yeah.
So then we can write, because sine A value we already, that we can write 1 by 1 by cosec A square. Right, so this would be how much? This is 1 minus, what would be this thing? This is 1 by cosec square A. Now, what is the next step? What is the next step?
Cosec square A minus 1.
We have to take the LCM. So this is
Yeah, LCM root of cosec.
cosec square A minus. So this is your cos A, right? Now you have found out cos A. So what is the reciprocal of cos A?
Reciprocal of
Cos A.
tan.
Not what, cos.
Oh, cos is sec.
So sec A would be 1 by cos A, right? This would be reciprocal of this thing. So this is cosec square A by cosec square A minus. So now you have written, right, every other trigonometric ratio in terms of cosec, right? So you have written cot A in terms of cosec A. You have written cos A in terms of cosec A, and then sec A in terms of cosec A. So every trigonometric ratio is written in the form of cosec A, right? And remember, we always write the reciprocal, and then in the second step we write the identity.
So even if they ask in terms of sine or cos or any other, we have to
Any
always
other.
do the
Yeah,
same
so
thing.
first, if they want us to write in terms of sine A, so what is the first thing that we can write? We can write the reciprocal of
The
it.
reciprocal.
So cosec A would be
1 by sinus cos.
sine. This would be the first thing you write. And then you can use the identity. So then you can write cos A, which is 1 minus sine square A. And then from cos A, you can write what? Cosec A. So sec A, right? from cos A, you can write reciprocal of this thing. So you can write sec A. That would be 1 by cos A, which is 1 by 1 minus sin. And then you can write using this thing or using, yes, you can use this thing cosec A to write cot, or you can use sec, right? Write tan. So tan is how much? Tan theta is, or tan A is
Got
6 square A minus 1. Right, so you can put this value and then you get 1 by 1 minus sine square A minus 1. You simplify this, you will get tan, and then you can write cot, which is 1 by 2. Everything in terms of sine, right? That is how you do this kind of problems. Yeah, please practice one, right, at your home. Let's say you write everything in terms of passing. Please do this question at your home, right? And if you get stuck, please so please note down this problem. Uh,
write everything in terms of cotton.
Then this question is cosec.
No, you gave a homework.
Homework is, yeah, write it in terms of cost.
Pause.
Yeah. So whenever you want me to scroll down the screen, please. Yeah. Whenever you want me to scroll down.
You can scroll. For sec, you wrote root of cosec square a upon cos.
Oh, so this is cos x squared, right? Cos x squared. So reciprocal of this, right? Cos x squared. Cos A is this, and then you take this square.
Oh, okay.
Yeah,
Yeah,
noted.
finished.
Okay, so now let us move on to the next question. The next question is from 88. Okay, so then we have to solve this question. So what is the idea that you will put the question? We are given this angle POQ, right? This is given 30 degree, and then you have to find the area of shaded. So this radius, what is that? So radius 7 centimeter. OP is 7 centimeter, and then the smaller radii OB for OD, that is 6.5 centimeter. So you have to find out the shaded region. How will you find that out? What would be area of shaded region? What do you think? Yeah, how will you calculate the area of shaded region? Let me give you a hint that what is
We have to minus the area of triangle,
my
area
triangle?
of sector, third area of sector.
Yeah, good. So absolutely correct. So this is the thing that you have. Big sector minus small sector, right?
Yeah.
Yeah. So what is the area of big sector? You tell me. What is
Yeah,
the
the figure is that one, right? Or is it the other?
this one? This one.
This one. So the area of the big sector is PQO or OPQ.
OPQ. Yeah. What is that? What is
The
that?
area of the big sector.
Yeah. Yes. Numeric. What is the What are the numbers? Numbers.
Oh, that is 7 centimeter.
So something like theta by 360 pi,
Oh, you're
and
saying the formula. Okay, theta
yeah.
by 360 into pi r square.
So R is in this case 7 square, right? And
Yeah, and the small will be OA.
theta by
That is
360
360 into
by
pi 3.5.
3.5. So it is 3.5, and it is better to write it as 7 by 2, right? Because the squaring the points that will be troublesome, right? Let's write it as 7 by 2, right? Because 3.5 is how much? This is 10. So 5, 7, 5 2 such. This is 7 by 2. 7 by 2. 7 by 2 square. Right, good. So this theta is how much?
Theta is 30, so 30 by
30 by
360, then times
360
7.
pi 7 square. And don't simplify this thing. Don't multiply. Until and unless we take everything common, then
You didn't
you.
write the pi value. Is it necessary to write?
Yeah, so we write every value we will put at the last. Right. theta is 30 is pi and 7 square pi. Now we will take the common. What is the common? Let's say cancel this thing. This is 12, this is 12. So what is common in these terms?
Pi and 7.
7 square and by 12 also. 12 is also common,
12?
right?
Yeah, 12.
Right. This is 1 minus 1 by 3, right? So then this is how much? 5, 7 square, 12. This is 4 minus 1 by 4. So this is, now we put the values. This is 22 by 7. 7 into 7. This is 3. This is 12. This is 1, 7 will cancel. This is 4. And then this is 2. This is 77 by 8 centimeters. That would be the answer, right?
Yeah, I'm solving.
Oh, you are also solving. Good. Yeah, you also solve that part. And I'll be back in one week. Yeah, so
Yeah, finished.
finished. Good. Then what is so a chord of a circle makes a right angle at its center. Find the areas of the minor and major segment of the circle. Right. So what we need to find out?
So we have to find the area of minor segment and major segment.
What is the diagram? Right. We have a
You have to
circle.
draw a circle. Then there's a chord.
Have a circle. Right. And then there is a chord, which is let's say this is the chord. and it is meaty. This angle is how much?
90.
90. This is 90. And this is how much? Let's say this is OA. How much is OA?
14.
This is 40. So this
So
is,
that makes me 40.
so what kind of triangle is this one?
It's a right angle triangle.
Right angle triangle. So what would be the area of this triangle? Area of triangle. Triangle. What would be that? What would be that?
Half into base into height.
Half into. So what is base?
Base is AB.
AB. Then what is? So then you won't be able to find out the height, right?
So OA.
Okay. And then what is the height?
OB.
What is the
OB.
height? Because this is a 90-degree angle, so perpendicular would be the height. This is
Yeah.
14 and 40. The area of triangle.
So
Okay.
we can cancel it with 7. 2 sevens.
7. Now we have to find out minor segment. So what would be minor segment? What would
Area
be
of
minor
triangle minus with the area of circle.
segment? You are saying what is the minor segment? This is the minor segment, right?
Yeah.
So you are saying that this minor segment is what?
Area of triangle. Minus.
Area of triangle. So this is area of triangle, OAB. And you are yeah, subtracting from this thing, you are subtracting. Yeah.
So to find the minor segment, we should add
And
or subtract.
you tell me what we need to, because there would be two things we have to add or subtract. Right? So what are the two things? So, okay, so let me first, or you first tell me that what are the areas that you have done in this chapter? What are the areas that you have?
Area of a sector, area of the length of the
Yeah. Area of sector and area of sector. These two areas you have done. Now, in this one, which what is the area of sector? Which one is the area of sector? Which one is bigger? Sector or segment?
sector.
Sector, right? So sector is this bigger one,
Yeah.
right? And then you have this triangle. Which one is the smaller one? Sector.
So area of sector minus area of triangle.
Good. Yeah. And these are minor sector, right? But I'm telling sectors, minor sector and then triangle.
No, I thought its major segment is area of